Now, in order to perform this integration here, we cannot be able to work it out since A is not E. Remember when we were having E is to maybe integrating E is to 2x plus 4 with respect to x, we could go straight, differentiate what the power is, and divide it by 1. So differentiating this one, we're going to get 2. Then we shall say 1 over 2. E is to 2x plus 4. Then we say plus c as the integral of that. Or if you are having E is to x squared plus 1 with respect to x, you'll go at the power, differentiate it, then you say 1 over the answer you'll get. This is going to be 1 over 2x, then E is to x squared plus 1, then we shall say plus. We cannot do the same since this A is not E, is a different constant. For instance, if you are having 2 raised to power x, you cannot do it this way because this number down here, the base is not E. You only do that when it's E. Now, how do we go about this? First, we need to convert this AX to be in the form E is to Z. That's the first thing that we're going to do, so that we will be able to integrate when we have an E there. So to do that, we are going to introduce ln both sides of equation star. So this is going to be ln ax is equals to ln ez, and you can see now, because this is a power, it can go behind, and then we shall say ln ax is equals to what? Is equals to z ln of e. And we know that ln of e is actually 1. So meaning that z is equals to, we can be able to write it as x ln of a, right? As the value of z. So meaning this expression that we are having here, ax rather, which means that a raised to power x is equals to e is to x ln of a. This one is equals to this. So meaning that when we are going to integrate, we can now replace this with this so that we can now proceed with the integration process. Can now say integral of ax with respect to x is the same as the integral of ex ln of a with respect. Now we can be able to use this method that we said here in order to work out this. So we are going to say that's going to be equivalent to, remember, ln is a constant. Ln here, ln of a is a constant. Ln of a is a constant. The variable is x. So when we differentiate the top, we are going to remain with ln. If you are having, for instance, 2x, you differentiate this, you are going to have 2. So here we are having the constant ln of a. You differentiate this, you are going to get ln of a. So meaning this will be 1 over ln of a. Then we shall write the expression the way it was, x ln of a, right? Then we shall say plus c. Okay. So at that given point, we cannot leave our answer that way because using the laws of logarithms, we can be able to take this power up, and this is going to be 1 over ln of a. E is to ln of a x, then plus c. So I've taken this on top here, but ln is 1. So meaning that the final answer will be 1 over ln of a. An expression like this, a ln of ax, you see we are having ln of ax. So this can be taken behind the exponent, and we can have ax ln. But ln is actually 1. That's why we were able to convert this to this one here, and our final answer becomes ax. Whenever you are having this expression like this, it will end up here, and that's why now this expression that we were having at this point will be converted to ax. Right, so similarly, if you were having ln over x cubed, then it means that this expression, this part that we have here, can be taken behind the exponent, and that could be what? That could be x cubed ln, and ln is equals to 1. Therefore, the expression becomes power 3. So always remember that. Now, we need to look at a scenario whereby you have the exact number here, how you can be able to work out with the exact number. Now, for instance, you are told to integrate 2 raised to power x with respect to x. How do we perform this integration with respect to x? First, we said let 2x be equals to e is to z, so that we can be able to find what is dz here in order to perform the integration. Then we shall say introduce ln both sides, and this becomes ln over 2x, right, is equals to ln of e is to z. And this means that now this power can be taken behind here, and we're going to say this is going to be ln of that is actually x ln of 2, x ln of 2 is equals to z ln of e. But ln of e is basically 1. This one will cancel to 1, so that we can have z is equivalent to x ln of 2 as the expression here. Therefore, if we are doing the integration of 2 raised to power x with respect to x, that is going to translate to what? We are going now to say is e is to z, but z is this part that we have gotten here, and that is going to be integral of e is to z, but z is x ln of 2, right? And we say that whenever you are integrating expression like this with the exponent, we are going to differentiate the power, but you see the variable is x, but 2 is a constant. So if you are differentiating x ln of 2, we are going to get ln of 2 as the answer. Then we shall say 1 over ln of 2. Then we shall write the expression the way it was, x ln of 2. Then we shall say plus c. So once we have this, we need to take this up the power here. Once we have this, we shall take this up, so that we can have our expression as written as 1 over ln this. Now, taking this back on the exponent, we are going to say this is going to be 1 over ln of 2. E is 2. ln of 2 raised to power x. I'm taking this on top of 2 so that I can have my expression this way. Then we shall say plus c. So meaning that taking this behind the exponent, ln will be 1. So finally, our final answer will be 1 over ln of 2. Taking the whole of this behind the exponent, we shall have 2x then plus c. Because when you take this behind the exponent and e of ln is going to be 1. So we're going to remain our answer with ln of 2, 2x plus c. So in simple terms, anytime you are going to integrate an expression like 8 raised to power x with respect to x, that point now from this process we have done, you can see it always becomes 1 over ln of the constant you have, then 8 raised to power x, then plus c, the way we have written there. If you are integrating 5 power x with respect to x, this becomes 1 over ln of 5x then plus c. So that is the way we have, that's how you approach that. So anytime you are given a question that way, remember you take the ln of the constant, 1 over the ln of the constant, then you write the expression the way it is. And of course, once now you have these answers, yeah, of course, once you have all these answers that we're talking about here, you can as well write this expression as, because this is just 1 here, you can be able to write this expression as ax over ln of a then plus c. That's just making it more simplified. This can be written as 5 power x over ln of 5 plus c. Right. This one can become 8x over ln of 8 then plus c, like that. What about this one? You can say this is going to be 2 power x over ln of 2 then plus c, like that. And then you are done. Now, in the event you are going to be given integral of 0, integrating from 0 all the way to 1 over 3 is to x with respect to x, then of course we have seen that this is going to become 3 is to x over ln of 3. We are not going to include the constant because we were provided with the limits. So we are going to say this is going to be 0 and this is going to be what? 1 as provided. Then in order to evaluate this, we are going to say this will be 3 raised to power 1 over ln of 3 minus 3 raised to power 0 over ln of 3. So this is going to be 3 over ln of 3 minus 1 over ln of 3. Okay, so which means that if I decide to simplify this further, what I'm going to do is that I will factor out. I can decide and take out 1 over ln of 3. I will remain with 3 minus what? Minus 1, like that. And then I'll have my answer translating to 1 over ln of 3 into brackets 2. And finally, our answer becomes 2 over ln of 3 as the final answer. And if you are leaving your answer in exact form, you can leave it this way.